Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss about the working principle of outward radial flow reaction turbine. In our last few lectures, we have discussed about the inward radial flow reaction turbine. Now we'll see how the outward radial flow reaction turbine will work. So here I've taken two diagrams. This is actually outward radial flow turbine, and this one is inward radial flow reaction turbine. So this part already we have discussed previous lectures. This one we are going to discuss today. So why I have taken these two diagrams, so that you can better understand by showing these two diagrams at a time, you can easily understand that what is inward and what is outward one and how it is working also. So the outward radial flow reaction turbine, actually here the water will enter the turbine at the center. So this is our center point. Suppose this is the center point, or you can say this is the your shaft part is there, like where the shaft is connected. That's why it is showing here, this one. And the water will enter at the center point of this turbine, and that can enter by axially or maybe tangentially. Okay, it can enter to this turbine by axially or tangentially, and that will move from the center point to outward. That will be moved outside or outward through radially. So how it is entering? It is entering axially or tangentially, but when it is leaving out, you can see the arrow mark from here, that how it is going outside here. And this is the center point. You can say that at this middle of this, the pipe will be connected at the center, and through the guide wheel, you can see the guide wheel is present here, and outer part is runner here. I'll tell you that between these two comparison, I'll tell you where it is situated. So the water, how it will flow, like from inside to outside. So the water will enter at the center point, and that will move out through this guide fence, and it will go outside of the periphery. So in this way, the outward radial flow reaction turbine will work. So first one is, if you make it some steps wise. So in the first one, the water will be come inside through the inlet. So inlet of the fluid, that will be enter to this turbine through like at the inlet, in the sense at the center point where it is there. First one, inlet of the fluid. Next one is, it will be flows from this center to out from this center to outside. That is radial flow. That is radial flow. First the fluid is coming inside, that is inlet of the fluid at the center point, and that flow may be axially or tangentially. After that, it will go outside through this guide wheel to runner, that is radial. That's why it is radial flow. By this meantime, your velocity and pressure will be changed. In this working, your velocity and pressure will be changed here. And when the fluid will started moving, okay, through the blades, because this is our actually guide blades. This part is wheel, we can say. This is wheel, we can say. In that wheel, the guide vanes are fixed. These guide vanes are there, which is fixed, so that when the water will be come out from the center point, it will give the directions to the water to go out. So these are this path directions, we can say, that is guide vanes. And the outer part is, that is runner part. The outer part is runner part, we can say. In the runner also, we have that number of blades are fixed on this. And so when it started rotating, you can see the water will be going outside. The water will start moving outside, and through this runner it will go out. So this is the principle. And meanwhile, as I told you, that the pressure and velocity will be changed because the fluid will be started moving through the blades. Okay, so the pressure will start decreasing. When the fluid started moving, obviously it's started expanding, because we can say the fluid started expanding and pressure also started decreasing. And meanwhile, when velocity will be increased, because we can see that this is the suppose runner part is there. When it started moving, so water is already started going outside, and due to this movement of this wheel, also again it will create another one force in that. So more the velocity will be increased at this point when it's going out, when the fluid is moving out. And there by this we'll get a reaction force will be created there. There is a reaction force will be created in the due to the change of velocity and pressure there. The fluid when the fluid will started passes through the blades, as I told you, there is a reaction force of the blade that is due to the pressure difference. Okay, pressure difference will be created. See, when it is going inside through the center, will have different pressure. But when it is passing through this blade and moving out, as I told you, that fluid started expanding, so pressure started decreasing. So this pressure difference will create a reaction force. Okay, and which makes the this turbine started running. Okay, so this is some steps as I told you. Now I'll show you that inward radial flow reaction turbine, and this is outward radial flow, how it is. When it is inward radial flow turbine is there, that time we have seen that the water used to come from outside. So we used to have a suppose at the outer periphery we used to have a casing part is there, and if you remember, through this casing part you can see the water used to come outside. This is guide vents. This two are guide vents. So here where is the guide vents? So guide vents is at the outer part. So when the water will come from outside, it will move towards from outside to inside. So how it is moving out, like how it's going inside, you can see these are the arrow mark I can give you. So these are guide vents. So guide vents at the outer side. And next is that normal vents are there, or you can say that it's moving vents are there. These are the moving vents which is connected to the runner. So here runner is at inside, which is connected to the shaft here, which is present at the center of this part. So this is the inward radial flow turbine. Now we can see the diagram also. This is guide vents are outside, and this is our runner part is there. This one is the runner part. So runner also having that outer dia. This is outer dia is there, and this is inner dia. This is inner dia, we can say. At this point you can see the inlet of this blade is at the outer diameter. Inlet of the blade at outer diameter. Okay, outer diameter means this one, that is D1, and outlet of the blade is like this one, which is at inner diameter, D2. This is for inward radial flow. But here if you see at the outward radial flow reaction turbine, here what is happening? We have that from this center point, from this center the water moves outside, it's going outside. That's why here if you see the runner part, where is the runner part is there? Runner part is the outer part. And what is present in the near to this center? Along with this is suppose our shaft is there, and here near to this center guide wheel is present. But at this point guide wheel is outside, but here guide wheel is at the center, and runner is near to the runner. The runner was at this near to the center or near to the shaft, but here the runner is at outside. So the water will be goes out from here like this. Okay, that is the difference. So you can see the diameter. This is diameter 1. If you see this one, this is inner diameter of the runner, and outer diameter of the runner is D2. Outer diameter is D2. While it is different, here it is D1 is more. Here if you see D1 is greater than D2. But here if you see that is D2 is greater than D1. So in this aspect, if you see D2 is more than the D1. So in this aspect we can say, we know that our tangential velocity or peripheral velocity, that is U1 also will be less than U2, or we can say that U2 is more than the E1. So this here we can see the tangential velocity of this part is like this. Okay, this is about the working principle of like how it is working of the outer radial flow turbine. Similarly, what about the velocity triangle will be there for this? This was the velocity triangle what we have seen for the inward radial flow turbine. At this point you can see here, this is the water fluid inlet. You can see at this point, this is the tangent part of this blade, like where it is entering. You can see where the water is entering at this point. So similarly, the water is entering at this point here, blade. You see the blade is there. So outer diameter you can see here R1 is there. Here outer one was D1. So here you can see the radius of this is more. That means R1 is more than the R2 because our D1 is more than the D2. So here if you see, this is our inlet of this fluid and this is outlet of the fluid. But at this condition what will happen? Though the fluid is coming from center to out, so here our inlet will be there, this one. As I told you, the inlet of the fluid will be at this point. So but velocity triangle will be same, like what we have done here, the same thing we can do here also. Only the thing is it will be in reverse mode. Only velocity triangle will be like similar velocity triangle, but we need to make it in like what we have done here at outer one here, that need to do at the inside one. So that is only the difference. Remaining things will be similar here, and these things we need to keep in mind. Okay. So these are the what I told you, like working principle of this outward radial flow reaction turbine, and some applications also there, and some comparison also there. If you want to compare this two inward and outward, we have some comparison like flow. So for this condition, let me write. This is suppose flow comparison will be there. This is outward. Let me write shortly. This is outward and one is inward. So in the flow analysis, if you see how the flow is moving here, I can do in this way, or just I'll draw a line in the middle. I just write shortly. Flow is here from center to outside, like from center to outer periphery we can say, or outside here you can say. Just I'll write outer periphery. But here what will happen? Now from outside, from outer periphery to towards the center. This is the flow direction of the fluid. Now here the speed control will be different here. So next is the control, speed control. Speed control means the flow, how the flow is flowing. As we can see, the fluid is coming from outside, and from outside through the guide vanes it is going inside. So there is a control of flow in the guide vanes. Okay, as I told you previous lecture also, I told you that the guide vane will be present here to control the fluid flow and to manage the fluid flow control, in the sense that will be control the velocity of the fluid. So at this point here we can easily control the fluid. We can easily control. Easily we can write here control. But at the outward radial flow turbine, it is difficult to control. Why? Because the water is coming from inside and it is moving outside. Though the water is moving outside, again it creates a rotational speed here with the help of this guide wheel is started rotating, because it needs to generate more power. So by this effect, it's getting more difficult to control the fluid velocity. So the fluid velocity is very, very high at that outlet point I told you. So it is difficult to control here. It is difficult to control the fluid. Similarly, here the centrifugal force, how it is acting, like it is acting from to outward side. So the centrifugal force, how it is acting. Obviously, it is very, very simple. We can say, though the outer radial flow, the centrifugal force is working to outside. Similarly, here it will be there in the inward radial flow. Obviously, it will work, acts to the inward, acts inward, as simple as that. Now, the next point we can say efficiency. So these are the one point. Just we can split it in this way. This is efficiency. So efficiency of these, actually it's depends. Okay, I can say that this will be in the outward one. It is more common actually when it is in large scale, but still it depends like what position and what location and how we are utilizing this one. But though it is difficult to control the speed, nowadays we are not using this kind of turbine. Mostly used to refer the inward radial flow turbine, or which is known as Francis turbine also. But here for the large scale also it can be used this one. And the inward radial flow we can use in the even medium scale also can be used. Even this one also can be used for the medium scale also. For the medium scale also we can use. And here discharge part I already told you that the flow control difficult in the sense here discharge is more, or we can say the discharge is increase in discharge. But here we can control the discharge so that we can write it is decrease or can be manageable, can be adjustable in this. So these are the some difference between the outward radial flow turbine and inward radial flow turbine. Yeah, now we'll see some applications of this, like where it can be applicable. So application of this outward radial flow turbine, even we can say that reaction turbine also, but mostly applications can be done of this outward radial flow turbine in hydroelectric power generation. In this case also can be used like hydroelectric, which is power generation. This can be one application, and along with it also we can use this for the steam turbine in power plant. In the steam turbine, like in power plant electricity generation also same thing we can tell. And along with that also I can say that in gas turbine, like the gas turbine also like in advanced power generation system like jet engine. Okay, if you tell this one, I can say here an example, that is jet engine can be utilized. And some other applications are there like pump and compressor that can be written under like mechanical drive. This can be also used in mechanical drive as pump or compressor, we can say anything. Okay, yeah, so these are the some applications are there, and these are some comparisons are there. I hope you understand. Yeah, one more is there for this discharge I have written. Here I can write one centrifugal head. Centrifugal head. Already centrifugal force acting I have written there. Here we'll get a positive centrifugal head, but here we'll get a negative centrifugal head in this point. So these are the some differences between inward radial flow turbine and outward radial flow turbine. I hope you understand. By seeing these diagrams, this is our velocity triangle. This is our velocity triangle, inlet condition, outlet condition. And this is also velocity triangle, this one for like outward radial flow turbine, and this is for inward radial flow turbine. You can see the difference how it is. Okay, and this is the flow directions as I told you, and here also you can see this one. I hope you understand this lecture. If you're having any kind of query and doubt regarding this, you can give a comment on the comment box. Thank you.